Our next mathematician is a French mathematician, Joseph Lagrange. Now, he was a great mathematician, but his greatest contribution was the development of the metric system. Now, in the United States and a couple of other countries, we still use customary units, but the rest of the world is on the metric system. This was his contribution. In France, when he was growing up, there were over 300 different ways of measuring area. So the government decided there needed to be a change. They agreed a meter should be equal to 1/10,000,000th of the distance from the North Pole to the equator. Once again, we use customary units, and a lot of times when you're traveling in different parts of the country, you may see signs that say something is a certain number of miles away or a certain number of kilometers away. So let's take a look at what Lagrange did and how he came up with this formula and how you can easily do it when you're traveling. If you see the number of miles, you can figure out the number of kilometers that it would be. So we know that 10 miles is equal to 10 plus 5 plus 1, which is 16 kilometers. And we can see right here that the 40 miles is 64. So let's take a look and see if we can see a pattern that's going on here. So the first number, 10, is the same. 20, 20, 30, 30. So obviously we need to start with that number of miles, okay? So let's just start with the next one, 50. So if we take a look at the pattern, 5, 10, 15, 20, well, I'm just gonna go 25. But let's see why that is happening. If we take a look at 5 and compare it to 10, that's half. 10 is half of 20, 15 half of 30, 20 half of 40, 25 half of 50. This works, so we're just gonna keep on going. 1, 2, 3, 4, well, obviously I'm just gonna take 5. So I'm gonna surmise right now, guess, 50 plus 25 is 75, plus 5 is 80, which would be 80 kilometers. So let's take a look at this again. All right, let's do one more. 60, we know we have to start with the 60. If we stay with this, 5, 10, 15, 20, 25, 30, half of 60 is 30, so it keeps going. And we're gonna take 1, 2, 3, 4, 5, 6. Then we're gonna take all of these numbers, which begins with 60 miles, and we're gonna have 96 kilometers. So instead of filling out this whole thing, we keep on going like that, but let's take a look and see if we can find something that we can formulate into something a little bit easier so that no matter how many number of miles we've got, we can figure out the number of kilometers. So the first number we're gonna say is n, all right? So the number of miles we're gonna take is n. We're obviously going to have to add something to that. Well, this second number was always half of the first. So we're gonna say 1/2 of n. Then we are adding, now somebody might go, well, it's 1, 2, 3, 4, 5, 6, just keep on going like that. But you need to represent that mathematically instead of just saying the next counting number. So let's compare this to n. 1 is 1/10 of 10. 2 is 1/10 of 20. 3 is 1/10 of 30, and we continue and we see that continues. So we're gonna take 1/10 of n. We add all three of these numbers up, which is going to be 1.6 n. So if you simply take the number of miles and you multiply it by 1.6, that will give you the number of kilometers, and that is the metric system that Joseph Lagrange brought to the rest of the world, our mathematician of the day.